So we'll be kicking off from where we stopped in the last video. In the last video, we figured out how to hook up, we created a view that was responsible for adding new content as a new search result to our page. And we made use of some third-party, some Flask extensions like Flask WTF and Flask SQL Alchemy. So just to be sure that we're all on the same page, let's try adding a new content. So Ruby on Rails, HTTP Rails.com. This is a web framework for Rails. And yes, our content is added on the search page. Now, today, we will be breaking our application into separate files. If we look at our application where we can see that we have every single thing in the same file. In a real web application, there's a high chance that things will be broken up into different files. A file handling the models, a file handling the forms, and another file handling the views. So following that particular convention, we are going to do the same thing to our project. All right, so the first thing we're going to do is we're going to create a package where we're going to put all these different applications, all these different files. And the name of the package, a package is literally a folder with a .init.py file in it. So a package is a way by which we bundle all our application exists under a particular namespace. You could think about it in that particular way. All right. So I'm going to call our package source SRC. I'm going to give it convert it to a package by making it under init.py. All right. Now the next step is to move our main.py inside this source folder. But because we are doing this, we have to ensure that our startup script will change the configuration. Now, instead of main.py, we're going to change it to source._init.py. And that is because we're going to completely replace all the content of this folder we're going to completely place every single one of them inside the init.py. And we'll train our main.py file away. Okay. So the next step is to create our models.py file. And this models.py file is going to consist of all our models. So coming back to our init.py, you can see our model is this search form. So we're going to cut everything. And we're going to paste it here. Now we know we do need the DB object. So we're going to copy this and cut this out too. And we're going to paste it here. Because we need the SQL Alchemy object. So we are going to copy this or cut it out because it's only useful in the context of the model. All right. So let me just use a single screen instead of using multiple screen. So I'm working on the file. I'll just switch to this. All right. So we currently have all our imports, everything that is model specific in its own file. All right. Now, coming back to the init.py, we need access to the DB object here so that we can initialize it to the app. So from .models import DB. And with that, we successfully initialized our DB object. The next step is to move our forms to the forms file, to the forms.py file. So we're creating a forms.py file and we're copying out the content of all our forms to be in that file. Now you can see our form mixes of both the search results model and with some specific. First of all, let us copy out all the specific form imports. Okay, that's not just everything. And we are moving them all to the forms.py. All right. Then you can see we're referencing the model search results. So we go to the models.py and we import the search result. And with that, we have copied everything out. Now the final piece of the puzzle is the views. So we're going to create a views.py. And now views.py, we're going to move all these fields. All right. And the render template functionality is being used by views. So I'm going to copy it. Now we can see that so we're only making use, and we're also making use of the search query and search results model. But models import search result. Now we can see we're also making use of the app instance. So from dot import app. Okay. And finally, we remove all the unused imports. We're not using Flask in this particular file, so it goes away. We're using requests, we're using redirect. Now, all these red squigglies that we are seeing, of course, they're helpful, but I'm going to set up my text editor so that it recognizes my virtual environment, event.py. So if you're using Visual Studio Code and you have the Python plugin installed, set Python interpreter and workspace interpreter, and I'm selecting this. So hopefully, well, it should work, but if it doesn't, it's all good. All right. So search form is also being used. So I'm going to the forms, import search form. And with this, we're almost done. Now, since our application is still getting kicked off from this particular file, we need a way to be able to point our views.py to this file. And we have to import it directly at the bottom, or alternatively, from dot import views. And the reason we have to put at the bottom is because we are initializing the app variable in this particular file, and this app variable is being used by our view. And if we were to put it at the top, we're going to run into a problem in Python known as circular dependencies. So because we wanted to avoid that, we made sure that it was the last line in our file. And in this place, only Flask is being used. So I move the brackets. And our database now exists in this source folder. So we could, if we don't want to change the location, we need to add a dot dot so that it moves from the base directory, which is this current source folder. It moves one step backwards, which is where it currently is, and the DB directory. All right. So with this, let's try starting up our application again. We shut down the old code. So deactivate source startup.sh to run. All right. And with this, our application should still work as expected. Okay, so our application is not working. Models supposed to be from dot model. So from the views.py or the forms.py, from dot models. And with this, okay, so it's complaining that no such table, search result. And why is that? Looks like the location of our file is. Let's remove this directory and let's see if we can still maintain our application working. We'll refresh the page. Okay, that was the initial typo. Okay, so templates not found. All right, we need to move. Our templates are outside the directory, so single one of them inside our application. So we move the static, and we've also moved the templates. So with this, for it to refresh our application, is rendering correctly. All right. So now, moving to the order of the day, we can see that we now have in our models.py, we just have a single model representing a table known as search result. Now, in this, I want to implement another feature whereby makes anytime a user searches for a particular parameter and we are able to find as one of the items in our search result matches that parameter, we want to create a counter variable that we save in our database that automatically increments anytime any of the results in our search database was found. That is a requirement. To do that, there are many ways we will go about that, but to do that, we want to introduce the concept of adding another table to another model to our database that tracks the counter of each result from the search result. So what am I saying? We have the search results. Let's say, for instance, someone searches for React. Of course, React.js was found. The counter for React.js becomes 1. If the person searches for another result and React.js was not found, of course, React.js doesn't show up in the search result. If somebody searches for React.js again, the counter becomes 2, and so on and so forth. So it means React.js needs a way to be able to keep track of its counters, as in anytime it needs a variable to be able to keep track of when it was found, and that variable is automatically incremented. So we're going to make use of a new model that is going to be tracking the counter. And that new model, we're going to call it search counter. Also go to inherit from db.model. First, it's going to have an ID field, db.column, db.integer, primary key is equal to true. Then it's going to have, of course, obviously, a counter variable. And that is also going to be an integer field. Then we need a way to be able to reference the owner of this search counter, because every search result would have a single instance of this search counter. So how do we keep track of that? We're going to create a variable known as result is equal to db.foreign key, and it's going to point to this search result. Now, I'm not sure of the exact configuration, so I'm going to go to the docs, Flask SQL alchem. Now we need to always make it a point of habit to always go to the docs when we're not sure of something. So I'm trying to model a one-to-many relationship. So here there is individual relationship, but in my own case, I'm interested in this. So I'm going to change it. But I'm going to make it a person ID instead of I'm going to change it to suit our work. Okay, we're going to call it result ID. So it's an integer, it's a foreign key, and is referencing right now. It's going to be referencing search result, search underscore result dot ID. Now the question you might be asking is, where does this search underscore result come from? This search underscore result comes from the table name of this our class. Automatically, if we don't specify a table, we can specify a table by specifying the variable double underscore table name. Well, I'm not sure of this specifically. Let's confirm. And specifying a table name SQLRK. Okay, so you must have mentioned the table name. So if we don't do that explicitly, SQLRK may automatically create a snake case variable based on the name of our class. So you can see here we're using camel casing. It converts this to a snake case, which is why we have search results in this case, and we're interested in. So we're assigning it the value of the ID. So with this, we've successfully created our new model, but it's not yet been added to our database. It just exists in Python land. Ideally, to add this new model to our database, we would need to literally drop all the existing data we had and run this function again. But we're not going to do that. Instead, because that will require us having to type out all the populated data we've already populated. So instead, what we are going to do is we're going to make use of a Flask extension that helps us to handle migration. And the name of the extension is Flask Migrate. So it's an extension that handles SQL database migrations. So the first thing is to install it, open a new tab, activate our virtual environment, pip install Flask Migrate. As installing, we should not forget to add it to our requirement.txt. So what is the all right? So we have Flask Migrate is equal to, you can see the format here, 2.0.4, 2.0.4. All right. So with that, we come back to our init.py and let's figure out how to configure it. If you have no idea how to configure it, the solution is in the docs. So we're interested in this Flask Migrate, import migrate. Then we're supposed to initialize it with the DB instance. Now, because we created the DB instance in our models.py, we're going to do everything in this place. So with this, we've imported the migrate object is to initialize the migrate variable. Or alternatively, we could do this from init.py. So after doing this, we up, and after initializing our DB instance, we can now create a variable migrate is equal to migrate app and DB. And with this, we are done. Now, if we're to run Flask, we have a list of different commands that we can run. Initially, we just add Flask run and shell, but now we have the DB instance. So if I run Flask DB, we'll see the list of all the commands we can run under the Flask that Flask migration provides for us. So now, what does, to kick off the process, we need to create the migration folder that keep track of the state of our database. You could think of the migration folder as version control for your database. So you're trying to track every state of your database, as in every state of where our database is at any point in time. So Flask DB init, and the migration folder is automatically created for us. We can confirm that in this place where we see the different versions. So after running that, the next step is to run the migrate command from the DB command as a parameter. So Flask DB migrate. So anytime we make a change to our model, we'll run DB migrate. So with this, it has run a bunch of scripts and it has created a file known as Sinai A something. And in that file, and so learning Flask migrations. So where is that? Inside versions, where our project does not seem to be picking it up. Okay, that's no problem. Okay, let's see if we can find it here. C9. All right, so it actually picked it up, just couldn't find it. So this is the file that it created for us. And with this, we can now run Flask DB upgrade. And with this, our table has successfully been created. Now, to confirm our table has been created, let us check our interactive shell. Now, Flask provides a shell for us. By running Flask shell, we have an interactive shell prompt. But we want to make use of IPython in this particular shell. So let's figure out how to do that, because we know that IPython provides a much more better testing experience. So question is IPython with Flask shell. And the plugin we're going to use is Flask shell IPython. So, of course, since this is only useful for development, we're not going to add it to our dependencies. If install Flask shell IPython, Flask shell IPython. And with that, we've installed it. So if we were to run Flask shell, now we have an instance to the IPython shell. So first start, note that we are now working in a package. So from src import models. So models dot search counter dot query dot count. And you can see that the result is automatically 0. Now you can see that we don't have to always be running with app.app context. That is because we're using the Flask shell extension, and it automatically wraps all our models in the Flask app context. So we can just run the query directly and we can get an immediate result. Okay. So we know that our table has successfully been created, and we want to confirm that. Let's check if we can view the content of our table. I think I have the extension installed for SQL Alchemy. Let me see. SQLite browser extension. Okay, so we've got SQLite viewer and SQLite manager. Let's view the content of our database. So we need to visit the website. All right, so open file or drop the file here. So let me find the file, come to our database, assignments, training, learning Flask. So this is our database. And with this, it automatically loads the table. And we can see that we currently have how many tables? Well, it appears that we currently have a single table. But if we were to refresh this, okay, search counter. Well, it's supposed to show the list of tables, but I'm not sure why it isn't. Let's see. Okay, so we can actually select the tables we want. So we can see search counter has been created for us, and we were to execute it, we don't get any result. And with search results, we can see all the populated data in our database. All right. So coming back to the requirement was that anytime we make a search result, and one of the results in our database was found, we increment the counter. So it means every search result must only have one instance of the search counter. So what does that mean? It means we need a variable to be able to track instance of the search counter. If it does not exist, it automatically creates it for us. And if it exists, it just reuses it. So I'm going to convert that into a property. We'll call it def counter. And like I said, we first check if it exists. So result is equal to search counter dot query dot filter search counter dot result ID is equal to self dot ID. So we're checking if there's any instance of the result ID which is keeping a track of, which has a foreign relationship with this particular ID, if it's equal to this particular ID, and dot first. Now, if the result exists, by returning the result, else we need to create an instance of it. And to do that, I can just call can just run result is equal to search counter result ID is equal to self.id counter is equal to 0. I'm going to call result.save. Now our search counter does not have a save method yet. So we need to create a save method in our search counter. So to do that, def save, and we now have to create the save method db.session.add self db.session.commit. So I'm going to return self in this case, so that I can just return the result from save. Return result.save. Because we know that calling save is going to end up returning the saved instance of the result. Now, I don't like doing the work of the creation and editing of this search counter. Okay, we're going to leave it like this. And with this now, if we're to restart our shell, I want to pull in the first result of the search from source.models import search result query.first. If I were to call aa.counter, you can see we're going to pull a first instance. And if I were to call aa.counter, which is the actual variable, it's going to be 0. aa.counter.result ID is going to be 1, which is aa.id's primary key. All right. So we've implemented the counter variable. Let us implement the increment action that should occur. So We're going to create an increment function in this place. F increment self, and in this place we just call self.counter plus is equal to 1 and self.save. So the plus is equal to 1 is the same thing as writing self.counter is equal to self.counter plus 1. Let me use a better color scheme. Okay, can we see the comments? Is this better? So we can see the commented value. But I'm going to stick with the default because it looks a little bit brighter. All right, I'll go close this. Okay, so we've created an increment function in the search counter class. So from our search results, we can just call self.counter.increment, and we know that it's successfully going to increment the value. So coming back to our views, let's implement the logic. So from the search page, we check the, right now we're just returning all the query results, but ideally we're interested in returning the query results for items that existed in this search. So let's implement that first. So search results dot query dot filter search result dot title. So we need to figure out how to specify, how to implement a case insensitive search query with SQL, because the user might not remember to type the word as the way they are. In this case, Google Drive, the person might just type drive, and the person types drive, we want Google Drive to appear in the search results. So case insensitive query SQL Alchemy, and with this we have the option of using the I like variable. We have the option of using the I like variable. So models.column.I like. So with that, models.title.I like search param. Now let's test it out. Come back, we go back to our search page, and we're to search for drive. And we're to search for drive. Didn't get any search result. So let's see if we can fix the problem. And we come back to import PDB the set trace. Remember PDB, our friend. So with this, we're to refresh the results. Our browser is going to pause execution. And it doesn't seem to be working. Let's refresh our page again. Okay, it doesn't look like that's kicking. Okay, we're currently in the search result, but it doesn't look like our query has kicked in. Let's, okay, our server has restarted. Try it again. And we are running into a problem at the moment. Our code isn't pausing. Okay, import pdb.set trace. Our code doesn't seem to pause, so let's shut down our server and restart it. And let's refresh the page. Okay, now our code is not pausing. So we were to type search param, but as using search parameter. Now to jump to the next line, we type in the N key. It runs the next line. So right now we're to type data can see the basic search query came out. So if I run data.all, we didn't get any result. So it means this our search query is invalid. It doesn't give us the result we want. Okay, so well, I'm supposed to append the .all command. So we need to figure out, we can remove this as search query. We need to figure out the correct implementation, which we're not sure of at the moment. So we know highlight is invalid. So let's try and find another one. You can see there's one here. There's one here which has more votes, but it appears longer. We'll come back to that. All right, so let's use that instead. Go to copy the implementation, scroll to the top of our file. Now, because this is a model specific query, it will be better for, before we use our implementation, if we could just call a class method in search result known as get result, and we pass in an optional search parameter instead of having to do all this query here ourselves. So by calling this class method, I'm passing in an optional search parameter. If there is search parameter passing, it knows how to fetch the result, and if not, it returns all the results for us. So let's go and implement the get results class method. So like I said, it's a class method. If get result. Now because it's a class method, it's going to have the keyword class method, and the first parameter is going to be CLS. Pick an optional search parameter. So search param is equal to null. Now query is cls.query. If search param, what we had before, or what we copied was this. Well, let's import all the necessary imports we need in this particular file. So we know we need the func. We need the func object from SQL Alchemy. And if there was a search param, then query is equal to query.filter func.lower, in this case cls.title func.lower search parameter. And at the end of the day, we are returning query.all. You can see how much easier this is. It's much easier. So cls.query is the same thing as search result.query. Here's a search parameter, query.filter, passing in, checking if the title is equal to if now this is a mistake. We're looking for high contents. We're not looking for equal to. So you can see this is converting everything to lowercase. It's doing a equal to filter, but we were interested in contents. So this particular solution still fails us. So let's see if we can find something better. Case insensitive in. Okay, this doesn't work for us. So the best way to figure this out is to go to that SQL Alchemy documentation. SQL Alchemy query docs. Okay, so we've got the query API. We also have ORM query. Okay, so there are a lot of information here. So let's look for the filter documentation. Filter, 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 filter. Okay, the information we're interested in, we can't get it without having to read through everything. So we jump down to querying. Okay, common filter operators. We have equal to, we have not equal to, we have I like, case insensitive. We have I like. You can see here they're using a percent ed. Okay, we've got in, we've got not in, we've got is none, we've got and, we've got or, we've got match. So match will have saved us, but does not work on some backend such as SQLite, which is our database. So with all the information that we have in the documentation, it doesn't look like there's a solution, but there's always a solution. The closest is this I like, and we've tested this I like and we found out that it doesn't work. But the reason why it doesn't work is because we didn't add the percent behind and before it. So with that information now on ground, we delete this and we have tls.title I like percent. I'm going to use substitution parameter dot format search param. So with this, let's see if this query eventually works. Okay, it's complaining of an error and it's working. So we can see how the documentation helped us to overcome our problem. So if from our Google search we don't seem to get the right result, always go back to the documentation to help you to figure out a way to solve your problems. Of course, it takes a while to get used to documentation, but by trying and going through the different documentation, using the different form of search available for you, you will be able to come up with a solution. And if you are stuck, you can always ask for help from other members of the community. All right. So, but right now, we are just searching on the title. What if we wanted to search on the body too? So let's say, for instance, now, instead of drive, I search for how to. Because how to existed on Google Drive, the result should actually come up. But you can see the result does not come up. So I just do want to search on the title. I also want to search on the body. But from our query, you can see we're just searching for the title. So in order to be able to search from different fields at the same time, SQL Alchemy provides an operation known as the or underscore. So we're going to, if we remember set theory, if two conditions are true, then the result is going to evaluate to true. If one condition is true and the other condition is false, because it's an or operation, the result is still going to evaluate to true. So in this case, we want to check if it found the search parameter in the title, or if it found the search parameter in the body. See in the body, in the content, then it would return either one it finds. If not, it just returns an empty result. So it's an or operation. All right, so let's implement the first. The title query is equal to cls.title.I like. Let's just create this variable. Search query is equal to, copy out this variable, Control X, Control V. Okay, So I like search query and the content query is equal to cls dot content dot I like search query. Now the final query is going to be um, if you're not sure how it works, you can always go to the documentation to find out how it works. Okay, so you can see it. Query dot filter. In this case, this is and. Let's do for all. Query or to put the two conditions inside the or function. So this becomes or underscore title query content query. And with this, if we were to refresh our page with this auto, we should still get a result. The result still came out because it's not searching the body. But if we were to search for something else, like say go to school or something, it doesn't bring out anything because you couldn't find it in both the title and both the body. It's okay. All right. So right now we're returning the result, but we're not doing any incrementation. So it means something needs to happen before we return the result. Whatever result we find, we need to increment all of them before we return it. So let's save the result here. Query is equal to query.all, and we're going to end up returning the query. So to increment all the results we find, for I in query, I dot increment, I dot counter dot increment. And that's because an instance of I is of type search result, and search result has a counter variable, and this counter variable points to the search counter parameter class. Instance is a search counter instance, and the search counter instance has an increment method. So that way we can guarantee that anytime we find a particular result, only after it has evaluated, that is only when it's going to increment. And with that, let's update. Of course, we can't see the results yet, but let's update our template such that in such a way that we can see the result. And to do that, we come down to our result.html, and in the title, we'll just add a pipe parameter and we display the counter. So we end up having data.counter.counter. And with this, if we're to go back to the previous search results, because the result doesn't appear to be showing, let's refresh the page. Now we can see 1. If we're to refresh it again, it increments by 2. If we're to refresh it again, it increments by 3. If we're to remove all the search parameter completely, and see everything shows up as 1 and it increments by 4. That is because we're not blocking search parameter. We're not blocking, we're allowing the whole result to show up if it doesn't exist. But ideally, we don't want to show up. We don't show up anything if the person does not input a search parameter. So to do that, let's fix that. Come back to our models.py. So query. So ideally, so else query is equal to query dot none. I'm not sure if there's a non query for SQL Alchemy. Let's find out. So Control F, none. Okay, and we have first, we have all. And well, I'm not sure if there's a non query, but let's try it out. If there's none, to complain. This query has no attribute none. Okay, So alternatively, you could just return an empty list. So there must always be a search parameter. So query is equal to, and we have to remember to use the dot all so that it evaluates the result. And with this, if the person does not put a search parameter, it doesn't return any result. And the person puts a search parameter, after it has found the result, and it increments it by 1. And with that, we successfully implemented a complex query with SQL Alchemy. So we can see that how we've decoupled all the functionalities. So our view just calls a particular class method. It doesn't care how it does the work. It just knows that the view does the work and returns the correct result. So our view becomes as lean as possible. It's responsible for handling all the intricacies that involves the model, all the queries. It's constrained to the model and it doesn't leak away to other parts of our application. And that is where we're going to stop for this class today. Oh, thank you.